Okay, take a closer look at the keys and the name board plate. You can see is again another piece of beautiful rosewood veneer. Book matched and balanced to make up the name board. And here we have the original label. Wonderful state of preservation. And finally, the ivories and the ebonies. They are, as per their era, pretty thick. And the fronts, oddly enough, look to be, well, they're not ivory, not ebony. We'll take a close look at the action later. I think they might be mahogany, but they're rather plain. I've seen these fronts with all kinds of carvings in them, but that's superfluous for an instrument, so I could see where Chickering would leave that behind. But the ivory itself is very nice. The ebony is pure and dead black, so very nice. And I don't think I even see a chip in it anywhere. Very nice. Before I move on from the case and such, this just caught my eye and I want to share it. Do you see how they've chosen that bit of veneer to lay out with its flares, one part parallel to that beam, one part parallel to this front in that wedge shape? That's just great. That's, I don't know, maybe they pulled this trick on every piano, but I'm impressed with it. That's just taking a moment to make your choice and putting the right piece right where it belongs. So, anyway, on with it. Okay, now got the lid up, and I suppose I should start with the general and move on to the specific. What we have here is a square grand, so named because it has 4 corners. They could have called it a rectangular grand, I suppose, but you know, why be accurate when you can be poetic? Anyway, in Germany, I guess these are called a Tafelklavier or Tafel piano, a table instrument, which makes more sense. But beyond that, this is an American square grand, a Boston square grand, a Chickering square grand. And the most interesting thing about it is the big metal plate in it. What that is a one-piece cast iron piano plate in a square grand. Chickering was not the first to do this. That goes to Alpheus Babcock of 1825. But here in 1841, Chickering has has filed a patent for this version of the one piece, and we'll go into what he says in his patent as being so interesting about it. But the one piece casting is a technological advancement for pianos, in that prior to this whole section over here would be one wrought iron plate, and this bar here would be another separate wrought iron plate that would have to be fitted in to the case. I don't know how many makers had any type of metal reinforcing in the back, over or behind the tuning pins or in front of the tuning pins. If you look at Babcock's patent, it's basically a one-piece ring that essentially fits into his pre-existing instrument. This is the first full cast iron plate, meaning it goes from corner to corner to corner to, well, as far as it goes. And that unit construction out of cast iron, it made an item so much stronger, so much more rigid than the wrought iron. Wrought iron's nowhere near as rigid as cast. And it lowered production costs, lowered production time, because castings are repeatable. These castings were made in the South Boston Iron Works by a man named Cyrus Alger. He's famed for developing ways to purify cast iron so it would be stronger in its basic character. I think he had possibly an early version of the Bessemer process. I'm having trouble separating the two. And he also perfected a technique of heat tempering cast objects at or just below their melting point, and apparently that allowed free graphite to condense into, or free carbon molecules to condense into graphite and strengthen the material into what they called gun iron at the time. If you've ever seen those stubby mortar guns from the Civil War, those were his specialty. So anyway, it takes a big pot of iron to cast a plate. So this type of technological advancement in pianos really kind of had to wait until someone had a friendly neighborhood arms industrialist, to take on a contract, and I'm sure he was very happy to pour, a couple hundred to a few thousand of these a year. I mean, you can only make so many cannon after all. Anyway, this plate is the advent of this whole age in pianos. Prior to this, everything was tiny little inserts or broken up composite plates. This is a milestone. And we'll take some closer looks at the details that come from the patent, as we'll see what Chickering was claiming was so revolutionary, and it is not what you would expect. Let me take this little bounce cover off here. There, that exposes the dampers. And the bead rail. Okay, now according to Chickering's patent, his useful and meaningful improvement to the arts of pianoforte construction in this piano, beyond all the other things I just went through, which is far more important, is this little bead here, this little ridge in the plate, cast as one piece into the plate. See, everything was a component prior to this. So this used to be made of wood. And my goodness, I can hardly see a piece of wood putting up with the strains that are involved here. But in the patent, he goes on to say that when that's a piece of wood, it tends to loosen itself from the body of the plate at various points and buzz and make poor termination and kill the tone. He also mentioned that there are many times we've seen them when they've literally just all those pins have picked that single piece of wood up and just picked it up, at which point you've got no real termination in the point, and the tone dies right there. And he's absolutely right. And something like this became pretty standard in pianos after that. This is common in uprights. Grands went on to use A-graphs. So did Chickering. But this time, this was the next stage advancement for good, solid string termination. And the other aspect of this plate, patented aspect, I must say, as I'm chasing down the patents here a little bit, see if I can get in here with the camera better, it's not turning out to be easy, is that little hole right there. The pin, or the damper the damper rod goes through it. Well, that hole is in a flange that's cast into the plate. Previously, there'd be a piece of wood screwed to the case somehow, or screwed to the plate somehow, and those little guide holes would have to be drilled in that, and that would come loose, and there would be myriad problems, at least according to the patent. So he has decided to create a ledge there and drill holes in it in order to guide his metal wires. I'd almost be chuckling about this, except that the next thing that he was to do in his grands was to cast a ledge vertically like that across the string line, right where everybody would have A-graphs in a modern piano. And he drilled holes just like that through that ledge that's just like that, and bushed them just like that. So this might seem a tad overkill for a damper guide rail, but it led to his bushed stringing ledge, which it needed to. It was obsolete for too long, but while it was active, it was a good solid system. And once again, it gave you a real rigid termination at one end of the wire, so that there's no energy loss at this end. See, there's no energy loss of the wire in this system here. If that was a piece of wood that was bouncing around or splitting or just not very well attached, there would be a certain amount of energy loss. And the thing is, it's the high pitch energies that get lost. So what you get is dull tone. You don't get buzzes so much, though that can happen. What you get is loss of liveliness, and that's a terrible thing to lose for something as simple as rigidity at determination. Let's see, and that's all the stuff from the patent that I can think of. The strings, the very bass strings on this, are worthy of some investigation, because they demonstrate some characteristics that aren't part of American piano building for the most part, but they are common in older European pianos, and this is kind of me venturing backwards in time. So, of course, Chickering was learning from Europe. There's just no two ways about that. He was improving on things. He was innovating. He was, industrializing up, mega stronging, doing engineering things, but basic techniques he was adapting from Europe in many ways, very, very influenced by Erard and Pleyel, just no two ways about it. And what I want to look at here is this is bass string, see? Looks like a modern, all these look like modern bass strings. I may even be able to zoom in a little bit just to show you that they're rusting, so they're iron wrapped. If I could zoom in on them, what you'd see is that they're, I believe it's tin plated iron was what they were originally covered in. But as you can see, the winding, like any modern piano, goes long, and then it stops, and you have a length of bare wire before the bearing point. Now, if I go to the other end of these wires, let me get this thing out of my way. Come down in here. Here's the bass string coming in to the bridge. And of all things, the winding just continues across the bridge and up the wire, and it sort of ends right before the loop. And all seem to end about the same distance. And if you go back here, all the bass strings do that. And there's the transition from plain wire to wrapped wire. And, well, this is 1841. I'm not sure why they did this, except that it left possibly, this area had give it the most weight down here that you possibly can to drive the bridge. But I guess they wanted to have as few loose spots as possible. And that all wrapped up in there. If it started to come a little loose, that would keep it quiet, the strip there. I'm not sure the difficulties they had back at this time, but this is a technique that I've seen in a lot of European pianos of the period. I just wasn't aware that they practiced it in American pianos. Don't see why not. They wouldn't, so let's see. The bridge is one last little interesting feature in this piano, in that this piano was made before the advent of the separate bass bridge. On most pianos, the strings, the section of the bridge that has the wound strings on it is separated and has been, this part from here to here has been separated off, generally moved over here, and in that sense you can keep your same string lengths in your bass. It doesn't compromise your bass. You might even improve it a bit. But all your longest plain wires, say, these through here, they're not limited by where the end of the the bass bridge has to be. So these wires can actually be swung over this way and lengthened quite a bit, thus improving this whole section of the piano more powerfully. And if you can blend your bass in, moving it over here gives you more freedom to pick your string lengths, pick your weights. It's just, the breaking off of the bass bridge was a major development in piano scaling. Even though, frankly, sometimes the first thing they did, they didn't actually move these around. They just shortened this and lengthened that. And it improved the tone right there. It improved that transition point. So, let's see. I'm going to see if I can't find a couple of notes on this thing that work. The top note. It is a note. Nothing's tuned. It's unfortunate, but it's a square grand. And the hammers are rock hard. We'll take a look at them. They're going to be very interesting. We'll look at the action in a minute. See if I can find the break. Okay, there it is. Last plain wire. First wrapped wire. Definitely a change in character. Let's see if there's anything down in the bottom here. Well, 1841. This isn't really representative. This really wasn't fair. This piano would mostly likely have a nice, sweet, reedy tone. Maybe someday I'll get to do one of these. But because of the way they're put together, they're just a miserable amount of surgery to get that played out and be able to get down and fix the board. So makes them kind of prohibitive. Anyway, I'm going to pull the action out and we'll take a look at that part of the mechanics and be done.